arithmetic sequence is a sequence in which the difference of consecutive terms is constant, like this one. Each time it went up by 3, correct? Constant difference. This one, each time it went down by 5, constant difference. These are arithmetic. The constant difference of consecutive terms of a arithmetic sequence, sometimes represented by D. Usually it's always represented by D. So you know, the difference is represented by D. Series, it's the expression formed by adding the terms of an arithmetic sequence. Could you be any louder? Crinkle, crinkle. At least you're throwing your stuff away, I'll give you that. Okay, so let's go down here. According to those definitions, tell whether the sequence is arithmetic. Does it go up by a constant difference each time? What's happening here? Plus 6, plus 6, plus 6. Yes, it's arithmetic. Okay? This one, it's plus 4, uh-oh, plus 6. So no, it's not arithmetic. Okay, so that's what you got to do in the beginning. Pretty easy, huh? Tell whether it's arithmetic. Then we're giving you a rule. And yes, you will get this equation on the quiz and test, because you have a few of them in this chapter. Although, I got to tell you, there was a string of emails yesterday started by Mr. Scott. He's like, nope, I don't think they should have them. Are you guys doing it? But the other teachers were like, yes, I always give it to them. Next year, if you're in pre-calc with him, you're expected to know them. So there's warning. Okay? What? I can't hear you. I don't know. He's a good teacher. He just, you know, he expects a lot. Knows a lot. He knows a lot. Wait a minute. I shouldn't. Here we go. Shh. So the beautiful thing is, this rule gives you the function if you plug in what you have to know. So n stays n. It always stays n when you're figuring out the function. Okay, n stays n. The rest of it you can plug in, like you'll figure out the difference and you'll see what the first term is. Okay, A1 is the first term. The difference you're going to figure out just by looking. So let's look at this. What's the difference here from one term to the next? What's the difference? Yeah, we're minusing 3 each time, so D is negative 3. And then we just plug in everything else to the formula. A of n, which is what we're going to find out. They don't know that. The first term is what number? That's what A1 stands for, negative 7. And then you keep n minus 1 times the difference we determined to be negative 3. That's not a minus 3. It's a multiply by negative 3. Okay? So I'm going to distribute that negative 3 and just make this prettier. Combine the two. And you can write it like this, or you can flip it. It doesn't really matter. And there's your function. Isn't that nice? Wouldn't that have been nice yesterday? I know. Because they said that you should really try and figure it out on your own. Now, we also have to find A of 20. So A of 20 would mean I would plug in 20 for what? N. Okay? Negative 4 plus negative 3 times 20. I'm kind of squeezing it on there. And A of 20 equals... Yeah, I wrote that down wrong. Negative 64. Okay. Easy enough? Okay, let's do one more then. What's the difference here? Plus what, plus what, plus what? Plus 9 straight across. So D is 9. Plus 9, etc. So again, let's just do this. Plug in what we know. The first term here is 59. I keep n in the formula, and I multiply that by the difference, which is 9. So A of n equals 59 plus 9n minus 9 when I distribute that 9. A of n equals, I'm going to write it this way this time. It doesn't really matter how you write it. If you were to plot the points of this particular function, what would they look like? It'd be a line, because that's a linear equation, isn't it? Okay, you just don't connect the dots. Don't connect the dots if you were to plot it. And A of 20 is equal to 230. Nice? So you got to do this, and you got to do this. Easy enough. Flip it over. You know it gets better. It always gets better. I'm just rewriting this up here because we're going to need it. Okay. This is a fun problem. Do you remember elimination in a system of equations? Well, you get to use it again. Okay? So it says two terms of an arithmetic sequence are A of 10 equals 148 and A of 44 equals 556. Find a rule for the nth term. So I'm just going to write this here so you realize what you're working with. A of 10 equals 148. So again, this bottom number 10 is my what variable? N. If we're using n, we're using n this time. And then this would be my output, or my poop. When I plug in 10, I get out 148. Okay, A of n. All right, so I'm going to kind of plug in what I know to this equation. Now, let me back up a little bit. To write this rule, you need A of 1, you need to know the first term, and you need to know D. And we don't know either of those things right now. So we got to work to find those. Okay? So I'm going to plug in what I do know for this first thing right here. I know that A of n is 148. I don't know what A of 1 is. I know that the n they gave me was 10. Minus 1, and I don't know D. You see where I got that from? I got it from the information they gave me for this first one right here. This is n, this is A of n. And I plugged that in. Okay? Yeah, we're going to have to do the other one too. I have to do summation now. So it's just like yesterday. Yeah, yay math. Yesterday we had sequence and then we had sums. Same thing here. You can do summation with arithmetic sequences. So here's the sum. I'll give you this as well. You'll have this. You don't have to memorize it. You need to just realize that n is talking about the number of terms you're working with. The rest of it's pretty self-explanatory. S of n means the summation. And what would A of I mean? What does that mean? A of 1 mean? The first term, right? Plus A of n. We'll see what happens with that. Whatever your last term is, basically. All right, divided by 2. So, what is the sum of the arithmetic series? So the first thing you have to do is you have to find A1. You got to find A of 1. What are my terms starting at? What number here? 1. So I'm going to take that 1 and plug it into the function to find out what the output is, A of 1. Okay, so that means I just do this. Negative 2 plus 4 times 1, because that's my first input right there, my first n. And that equals 2. So that's A of 1. Then I got to find A of n. Well, what's my last term? What is my last term here? It's not term, I'm sorry, it's the last input number, 28. Okay, so I'm going to find A of 28. And so it's negative 2 plus 4 times 28 equals 110. So then in the formula, this becomes my A of 1, and that's my A of n in the formula, the last thing that I had to find. Well, when you're doing the summation, it means the last number in that long series. That's what it means. You're finding the output for the last input number in the series. Does that make sense? Okay. Now we plug it into the formula. So S of n equals, how many terms total do I have? 28, right? Because I'm going from 1 to 28. So I have 28 total terms, number of terms. And then A of 1 we found out to be 2. And the last term we found out to be 110. And all of that divided by 2. So if I were to add up for this particular function, the inputs 1, 2, 3, 4, 5, 6, if I would add up all the outputs, I would get 1568. It's just a way of summing all those outputs. Sum of the terms between 1 and 28. The sum of all the terms between 1 and 28. How you feel about that? I was really bummed out that the picture didn't copy here. There was a picture. And it's a fun kind of problem, so let's just look at it. So it kind of looks like this. Okay, and then it's kind of like this. Not that you'll ever see a brick building that looks like this, but whatever. Work with me, okay? So I'm just going to do one more row. There's 5 in this row. Okay, write a rule for the number of bricks. How many bricks are there in the nth row if the top row is 1? So this is a row 1. How many bricks are in there? 1. So it's really just going to be A of n equals n. If I was in the second row, there's 2 bricks. The third row, there's 4 bricks. Correct? That's my rule. That's way too easy, isn't it? But there's more. Let's do it. What is the total amount of bricks if the bottom row has 44 bricks? Okay, so if I think about what I'm working with here, how many terms do I have? 44. Okay, so I'm going to write this out. S of n. I'm going to have a total of 44 terms, 44 rows. My A of 1, my first term is going to be 1. Output of 1. The last term is going to be an output of how many? 44. Divided by 2. There are, anybody want to guess how many bricks in a stack like that? Too big. 990 bricks in a stack like that. Just in case you ever really wanted to know that.